grading your quiz. Um, the average around 58. Yeah, 58. Yeah, around 58. So I will deliver the result maybe around maybe 2:30 or 2:40. Okay, 2:30 or 2:40. Um, Before we continue to chapter 8, I think I need to review the quiz. Okay. Okay. So I think as I mentioned last week when we did the quiz, the easiest question is actually number 4, right? Number 4. And if you want to look at number 1 or number 5, number 5 is it's actually not too difficult if you are uh, correct in all your equations. It's not too difficult. Number 2, I believe some of the part, if you are not understanding the graphs, if you don't understand the graph, not understanding the curve, you will confuse which method you want to apply, the disk method or shell method. Okay? So you need my suggestions, even though it's not necessary like number 1 is sketch the gradient, but number 2, I believe you will be easier to solve. It will be easier to solve if you draw the curves. Okay. I think a few of I think I've seen in some answer a few of the students they couldn't draw the graph correctly, and then they make wrong conclusions. So I believe, especially sine and cosine, I think you need to draw correctly, okay, for sine, cosine. And then the quadratic functions, okay, please, okay, it's really basic. So if you cannot draw this, and I believe it will be going difficult in the next courses. Okay, let me start with the number 1. Okay, number 1, uh, draw the 1 minus 2x squared, and then you have the absolute of x. Absolute of x means you have minus x here and x here, right? But we need just to see this area between this blue and green curves, okay? And because it's only the area, what you need to do is you need to just the curve on the top minus the curve on the bottom, okay? But because it's symmetry, and my suggestion, if you are not careful when you are doing plus, minus, you see this is minus, right? This is minus. Then you can just see this half part and then multiply by 2. That would be much easier, okay? But if you're writing correctly, calculating correctly, you can calculate from here to here if you want, okay, if you want. But I'm not suggesting that. But that's just 0 and then half and then multiply by 2. And then the top one is 1 minus 2x squared, and then this is just the positive x, right? It's much more easier. Okay? So if you're thinking too hard, like, okay, well, how about the minus x? You will be getting wrong here. You will be getting wrong here. Okay, minus or plus, right? But if you just see the half part, okay, you just need to see the y equal x and then 1 minus 2x squared, right? Multiplied by 2, you get the result is 7/12. So half, negative, and then you solve this, multiply by 2, and then 7, 12. Okay. Okay, that's it. Number 1A. And the number B. First, draw the graphs correctly, please. Okay. So sine and cosine. Okay. If you see the like this absolute value, meaning in terms of sine and cosine, sometimes sine is on the top, sometimes cosine is on the top. So meaning we need to evaluate all the possibility, okay, from 0 to pi over 2. Okay. Now draw the curves and then see from 0 to pi over 2. This is the cosine, the green one, the cosine, the blue one is the sine. The cosine is 2x, right? So the degree will be half. Okay. Usually you get 0 in pi over 2. Now you get pi over 4. Okay. So if you remember physics, it's like the amplitude periods frequency problem, right? Okay. So you get this cosine 2x. And then you have intersections here in which you need to solve to find the intersections. Okay. Solve to find the intersections. You need to remember, at least remember the quadrant in which sine, cosine, or maybe tangent, negative, positive. Okay, remember that. And you find it's pi over 6. Okay, here pi over 6. So we can become two area. Okay, from 0 to pi over 6 and pi over 6 to pi over 2. Okay, so 0 to pi over 6 and then pi over 6 to pi over 2. And now you need to calculate carefully. Okay, calculate carefully. So cos 2x integrations is sine over 2. Okay. Sine become negative and it become plus. And this is sine become negative. So I put negative outside. So cosine and cosine become sine over 2. And evaluate all. And most of you getting wrong here. Okay. Getting wrong here. Up until here, I think almost half of you are correct here. But here, most of you are did wrong calculation. But here is correct. Here is correct. But here is wrong. Okay. So it should be square root of 3 over 2 minus 1. Okay. Don't worry. Up until here, you still get like almost full point. Okay, almost full point. Because this is sometimes it's difficult to avoid the mistake. Okay, to avoid the mistake is difficult. Okay, so this is the answer. So that's number 1. Okay, number 2. Okay, so you have the curves is the line y equal x and y equal 4x minus x squared. Okay, 4x minus x squared is this blue one here, and this is y equal x. You can try to find this point first, intersections. You get intersection is, of course, it's 0 and 3. You get from the equaling both equations. Okay, and then what is the rotation is y. Okay, so here's the rotation. Okay, you can use the dx if you want, but I prefer you can use dy if you want, but I prefer the dx here. Okay, and then it will be using the shell method. My suggestion is shell method because it's not too difficult to calculate because you will get clearly this whole curve minus this one is the height, right? And this length here is the radius. Okay? So the radius is just x, okay? Any x that changing around here. Okay? So you can just write x, and then 3x minus x squared is the height. Okay, the difference between 4x minus x squared minus x is become 3x minus x squared, and then you just solve this, integrate, and calculate 0 and 3, and you get the 27 over 2. Okay, I think around half of you correct, but here I think most of you correct here, and here is wrong. I don't know why, but I still give. I think this is 10 point. If you are maybe wrong here, maybe I give you 9. But I think if you just get here, I think I give you 10. Okay? You can check later. Okay? And then the B questions. So x squared plus 1 and 9 minus x squared. Okay. So this is x squared plus 1, and this is 9 minus x squared. And what you need to do is you need to rotate this line. Okay? Y equal -1. You can look for the intersections. It's 2 and -2. Now, if you want to use the shell, you will be divided by this line, right? These intersections, right? So I think that this method is preferable. Okay. In order to draw and calculate the volume, I believe drawing what the rectangle looks like when you rotate is important. Okay? Because you will choose from only two methods: disk or shell. Okay? Disk or shell. And if you think that when you rotate, okay, it looks normal, then you can do it. Okay? But if you see any restrictions, like maybe like this point here, oh, maybe this will be weird if I'm using the shell, then try to use the other rectangle. Okay, I think this way it will be better way, right? It will be like if you rotate here, it will be like a donut, right? So I think it's preferable this way. Okay, so the radius will be, we have two radius. This radius, right? What is this radius? Now you may see this is -1, okay? But when we are looking at the radius, we can just using the absolute value of that -1, okay? So this is 1, right? The length. This is 1, and this is 9. Where's, oh, here, 9 minus x squared, right? So plus 1 is 10 minus x squared. So that's the length. You just calculate directly. So do not. I think some of you are making mistake and confusion about this -1, okay? Because you are measuring the length. You can just measure its length. Okay. Do not worry about this negative, positive. Okay. And same way with this radius. It's 1 plus x squared plus 1, right? So we can use the disk method, in which you can apply the outer radius minus the inner radius. Okay, you get some part here, some calculations. There's some numbers here, but I think this number, because you only use 2, I think it's doable, and you can find it's actually 256 pi. Okay. Okay. Now the first term. Okay. The first term. You need to find the volume. Okay. One way, beside the integrations, you can use just the volume. Okay. You see, it's like a big cone, right? Minus the small cone. This is h. You can use this is maybe x, and then you can use the triangle and find the x in terms of r, the big R, and then h. And eventually, it will lead to the same result. I think a few of you using that, and then it's correct. And I still give a full point. That's correct. But if you are using the integrations, see the rotations. Okay, see the rotations. Rotations here, right? So if you have like a line here, then this line, when you rotate to here, it will be going to looks like this prism. So we can see from this triangle, we put y and x axis. We can look for the line equations. Okay. Imagine this is a line with some gradient, and we can find the gradient by looking at this length divided by this length. Okay. But because the gradient is going down, it's negative, right? So the gradient will be negative h over the big R minus R, this length, okay, this triangle. Okay. Now, going for the line equation, we can put our point, the big R 0, and then the small r and h. We put the point and we get the line equations. Okay. This line equations, rewrite the form, and we get x is actually the big R minus small r over h y. That's our equations that we are going to use. And it looks correct because actually we want to rotate to the y-axis. And if you look if you want to use the disk method, then dy is our choices, right? And it's already y, so we can use the whole equations into our integrations. So our integrations will be volume. We can use the disk method. Okay, the whole equation and just square it. Okay, it's a pi r squared and then dy and then integrations. And we need to solve this. Put in 0 and h. Solve, and then we simplify the form, and we get the results. You get the results here. It's quite long. I think if you are just using the geometric volume, I think that will be faster. I think that will be faster, and it's the same answer. Same answer. Okay, now as I said in the quiz, this is the easiest question that I gave to you. Okay, I hope you get correct. Almost all of you get correct by 4 over 5. So the formula, okay, because it's asking average value, you need to include 1 over b minus a. Okay, or let me write here. Okay. So average value is 1 over b minus a, and this is a, b, fx dx. Okay. So forget about this b minus a. Okay, b minus a. So from our questions, we get 0 and pi over 4. So we can get 4 over pi here. And secant squared is just tangent. So you can use tangent t, and then pi over 4 is 45, tangent 45, 1, right? So when you are throwing your ball, the maximum will be 45 degrees that you can reach the longest range, right? 4 over pi. Okay, number 5. Number 5, we have two curves, okay? X squared minus c squared and c squared minus x squared. Basically, it's the same curve, and then you just flip the curve, okay? So you can just equaling this, okay? And you get this is the roots, negative c and c. If you want to check, okay, that's correct. And then the integration is the top minus bottom. And you already know that it's 576, right? From the information. We can use the symmetry. You can use 4 and then just calculating this. Integrations, putting c inside and get 216, and its cubic root is 6. Okay. I think most of you correct, but uh, I think most of the mistakes is when you are integrating and there are like positive, negative, and you did wrong there. Okay. Okay, that's number 5. And the last questions, it's a little bit tricky. Okay. Okay, what I did is I'm putting A for point P, and then that P is 2x squared, right? So I have 2a squared here. So the coordinate will be A and 2a squared. Okay. A and B is equal. Now, if we are looking at A, we can try to find A first, the area A. From 0 to A, we can use the dx, right? 2x squared minus x squared, and then we get this. At least this is, I believe, I think half of you get this 1/3. That's a good direction. Okay? But most of you are going wrong direction in evaluating B. Okay, B. If you look at the graphs, okay, it's this. If you are looking for the dx, it will be a little bit difficult to evaluate. But if you are seeing at dy, it will be much easier. Okay. Okay. So you can change to all in B information into y. Okay, into y. So the curve will be square root of y/2. From the 2x squared, you get y/2 square root. And then C, okay, remember, based on the information, C is not a constant, but a curve. So I will write C and then I'll put y here. So you know that, okay, this is a function, okay? And then 0 to y, our y is in P, right? So 2a squared, so 2a squared, okay? And we can try to integrate, okay? Let's check the integration. So the left part, we can integrate easily, but the C, let's just let C having the integrations itself. Okay. Okay. So you get this integrations, and you can put 2a squared inside. You can calculate and just leave this for now. And then the next step is all this b is equaling the a. Okay, equaling the a. And now what you need to do is you need to solve differentials. Okay, differentials. Okay. So you get this. You plug in, you get 4/3a squared, a cubed, and this still c with integrations, and it's equal a, right? The a area a. So to solve that, we solve 1/3, and it will be a cubed is equal these integrations, right? And to remove the integrations, we can do the fundamental theorem of calculus. We derive this whole integration. Derive the whole integrations, and we get derived with respect to a. Derived with respect to a. So we get the 3a squared, and then we put 2a squared inside, and don't forget to chain rule the 2a squared become 4a, and we get the this function is equal to 3/4a, and this is actually y, and then we can exchange a into our equation square root of y/2, and then we can write down this for x. Okay? So this is because this is function of y, so it means that this is actually our x. Okay? So we solve x squared and we got this, and we can write down the y equal 332 over 9x squared. I think a few of you get, I think around maybe 7, 8 students get correct, 32 over 9. Some of you are missing the last point, but I think most of you get the 1 over 3a cubed for area A. Yeah, I think that's already good. Okay, that's the quiz. Okay, any questions? Any questions? Okay, so yeah. Okay, I think this is the last week. Have you learned the arc length function or arc length, only arc length? Okay. Okay, let me start with the arc length function. Okay, so another way to write down the arc length in terms of the functions. Okay? So suppose you have the initial points, okay, the P, okay. Let's say the initial point is from A, and then you want to write down your terms of arc length in terms of functions. Okay, so you can write down. It's quite similar with the how you write the fundamental theorem of calculus. Okay, you integrate. You have a constant. You have x. Okay, and x is any x that make the functions continuous. Okay, and then this is the result from the arc length our formula. Okay, and we can rewrite this, and we can see that if we differentiate s of x, we can have the differentials. Okay? dx over dx is square root of 1 plus f prime x squared. And this terms is this arc length function. Okay? We call this as arc length function. And remember, we can write also in terms of differentials of arc length. So we can write okay, depends on the case. Okay, I think I've mentioned last week, you can have dy over dx or dx over dy, up to you. The result should be the same. Should be the same. And I think the considerations choosing dy over dx or dx over dy, it depends on the curves. Okay, which one you think is easier to be computing. Okay. So that's the arc length functions. I think I will move to the next section about this surface area so that we can have more all the concept for chapter 8. Okay. So chapter 8, we only need the arc length and the surface area. Okay. The other part of the chapters like 8.3, 8.4, we don't really need to worry about it. Okay. That's the arc length functions. I think I will write in the new page. So now is the area of surface revolutions. So if I have this curve of, let's say, C, okay, and I want to rotate this C into about the x-axis. So I will, at least I'm having this curve, right? Okay, what surface area means, okay? Before these sections, uh, you already familiar to rotate and then find volume, right? And we can use the disk method, shell method, and so on, right? But here we are focused on finding the surface area. So imagine this is like if you're having maybe quite long here. Okay? It's like a glass, right? It has a hole, and you only need to calculate the area in this band. Okay? So imagine you can cut this open, and probably it will be similar to rectangle, or approaching similar to rectangle, approximately. Okay. Okay. And before I'm telling you how to prove all the surface area, let me give you a brief review. Okay. So imagine this is a cylinder. So let's say this is cylinder. If this is R, this is H. What is the lateral surface area for the cylinder? If you see the total surface area means area circle, you have two circle plus this area, right? The surface area. Okay. But lateral surface area means we're only calculating without the circle. Okay. It's only the band. Okay. And how you calculate that? I said before, we can cut open and we can see the rectangle, right? So let me draw the rectangle. And let's say this is H, right? This is H, and this length is the circumference, right, of the circle. Okay, this is 2 pi r. Okay, and the surface area will be for this rectangle 2 pi r and H, right? So I can write this as the area will be 2 pi r H. Okay. Okay. Now let's go to the next simple geometric form. Okay, now I have the cone. Let's say this is R, and let's say I have L, this length. Okay, and I'm not sure about today, but you you wear hat when you were having birthday? No, when you're small, no. Okay, okay, I think that's too old. Usually kids wearing the hat and then well, happy birthday. So okay, uh, maybe when you are in the kindergarten or in the elementary school, have you like making one by yourself and glue and then wear? Right, right, yeah, yeah, okay. So if we cut open here, it's actually we can see the let's cut here, okay? Let's cut. So this, okay. So maybe like this one, okay? It's not really the same, but yeah. Imagine like when you are making the cone, you're gluing this side to here, right? Okay, let me put angle theta here, okay? And this L is still the same L, okay? But the circle here is this one, right? The circle. So this length is 2 pi r, okay? Okay. This is called a sector, right? A sector. So if you have circle and you cut the circle like you cut a pizza, right? This part of your pizza is called sector, okay? Sector. So if you want to find the English term, it's called the sector. Sector. And based on the sector, this is equal to pi r, right? Okay. So the area, if you want to include all the terms here, is theta over 2 pi. Okay. Just imagine this is a big circle, right? And theta over 2 pi becomes the ratio of this sector, right? And this is just the circle area, right? So this will be half L squared and theta. And then theta, we can write 2 pi r over L. And we get pi r L. Okay, now we already have the cylinder, we now have the cone. And now actually the the object that we want to approach is actually the object in your quiz, the frustum. Okay, because most of curves, when you rotate, it will at least having like a smooth side of. So imagine any curve you have, and try take a small segment, and when you rotate, it will be a frustum. Okay, so let me draw a frustum for you, and let's observe, and we can try to compute the surface area of frustum. Let's say this is R2, this is maybe R1, and let's say this is L. This slide here. And let me make uh, another cone. Okay, so you can see it will be having a big cone and then small cone. So the first term is the big cone minus the small cone. Okay. Okay. And this part will be, let's say, L1. And let's say this is this line. Okay, now let's compute the area of the big cone. The area of the big cone, let me write. The area of the big cone is pi R2 and then L1 plus L, right? Based on here, based on this pi RL. Okay, we already calculate pi RL. So based on our picture here, it will be pi R2 L1 plus L. And an area of the small cone, and the area of frustum, we minus them. So I will skip some process and directly simplify, become R2 minus R1. Now we have also the triangle. So this is R1, R2, and this is L1, L. So L1 over R1 is L1 plus L over R2. Okay, based on the triangles, okay, the congruency of triangle. Now we can write this as L1 R2 and then R1 L1 plus L. And we can solve this and we get R1L and then R2 minus R1 L1. Okay. So area of frustum become pi. if R is half this is average radius, so A is becoming 2 pi RL. Okay. So exchange all this, okay, from the frustum, and we get the frustum become pi R1 plus R2 multiplied by L. And if you want to make R1 and R2 becomes the average radius, we can simplify the formula become 2 pi RL. Okay? And this is the formula that we want to approach, okay, on most of the cases. Okay? So 2 pi R is the circumference, the L is the sides. Okay. So if we look at the curves, okay, if we look at the curves, let's say here, so the L will be this one, and the R will be this one. So if you rotate with X, your radius will be what? Yeah, your R will be Y. So 2 pi Y, and then this is the arc length, the L. Okay, so this will be the arc length. So to find the surface area, first, before you maybe compute all together, you can compute the arc length first, and later put the arc length inside the 2 pi RL. Okay. So the formula is just 2 pi RL. Okay. This is radius. This is the arc length. Or sometimes you can write ds, okay, for the arc length. To note that the arc length that you pick up from the curve is very small. It's very small. Okay. And depends on the rotations. In this case, it's y. But if you rotate to y, then it will be x. Okay? Your radius will be changing. I will summarize later how we are using the surface area. Okay, I think that is the easy way to understand the surface area. Okay, if you look at the proofing in terms of mathematics, we can apply the same or similar approach with our arc length. So we can define this curve by segments. Okay, let's say P0 and then P, let's say I minus 1 and then maybe PI here, or maybe it's too big, maybe here. And then if you rotate here, we will be having this kind of surface, the frustum, right? And let's say we are compute until Pn. Okay. And if we decide to set the L is P distance of Pi minus 1 and Pi, and our average radius is the 1/2 So our surface area 2 pi, and then the r is divided by 2, and then L is, and let's write down the arc length formula. So 2 pi and then arc length formula. I just write 1 plus and then delta x. And we can write down this the radius becomes the functions. Okay. So we can also write this become only functions of, let's say, the sample point x and then we approach this with limit. This is sigma from 1 to n. Okay, because we need to compute all the Preston. Okay? We add plus, 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 plus. Okay, and these terms becoming our integral, right? Become our integral. So we get the surface area is integration from a to b 2 pi f of x 1 plus dx. This is for y equal fx and x is in between a and b. It seems like you need to memorize quite long, but actually no. Okay, you just remember 2 pi RL. Okay, 2 pi RL. Okay, and how you integrate it depends on your arc length. Depends on your arc length. If your arc length is in a functions, maybe function of x, then all will be the dx, right? And if this is y and you need to calculate to x, then you need to y is equal with the function of x. You need to just write the function of x here, okay? And it will be all with x, right? So it can be dy dx, it can be dx dy, and then dy. Okay, depends. You can change all the possibility here. Okay? As long as you are consistent. Okay, consistent. Okay, in summary, okay, let me write the summary. Okay, so for rotations about x-axis, our s will be 2 pi y. Let's say just ds. Okay, it's just ds. If you rotate to the y-axis, then uh, this will be 2 pi x, right? ds is the arc length, y is the radius, and this is x, the radius. Okay, any questions? No? So actually, the surface area, as long as you remember it's 2 pi r L, and you know L is arc length, depends on rotations. I think it should not be that really difficult. Okay, so I think uh, the important uh, if you are working on the surface area, I think the integration part, if the functions is quite complex and maybe relate to some techniques to solve, I think that will be quite a problem. But the surface area itself or the arc length itself is uh, not too difficult. Okay, the arc length is only square root and then 1 plus the dy dx squared or dx dy squared dy or dx. And then rotate y-axis, it's x, the radius. Rotate the x-axis, it's become y, the radius. Okay. I think I can deliver the quiz to you, and you can check your score. Okay. I need someone from uh, the global department, the IITP, and the College of Engineering. Maybe one, maybe Jack. Can you help me? Um, I'm putting question, answer, so you can take like question, answer like this. Okay. And this is, you can call. Ranking is, yeah. Whoa, whoa. You also, right? Maybe you can check if there's other students. I think this is zero, and this is zero. Hmm? For name difficult. For name difficult. But for area, for I think I can read a little bit. This is. Oh yeah, this. I think this is. Think, oh, this. This one.